Hello, this is Scholar Shack doing some algebra. Today we'll be solving compound inequalities. And it's just inequalities that are, there's like two or more separate ones and they're joined by the word and or. So if we use and, it just means where the two inequalities overlap. So where the graphs overlap. So an example here, we have x is greater than negative 2. So we make an open dot at negative 2 and it goes to the right. Here, let me make sure you can see that. So that's the shade portion here. And then we have another one, x is less than or equal to 1. So we make a solid dot and then we shade into the left. Now, if we wanted to combine those two by using and, that means it's just where they overlap. So we have an open dot at 2 still, and we still have a closed dot at 1, but we don't go anywhere else except in between. One way of looking at it is this has to be true, and this also has to be true. So we can't go any farther, or we can't go less than negative 2, and we can't go bigger than 1. Or, yeah, okay. So, or we just combine. Let's go back to, or means putting the two graphs together on one line. So here we have x is greater than or equal to 0, so we make a dot and then shade to the right. And then here we have an open dot, shade to the left. When we use or to combine these, we just graph both. Doesn't matter if they overlap, we just graph it how it is. So and that's that. So let's do some example. Translate the verbal phrase into an inequality, then graph the inequality. So all real numbers, let's call that x, are greater than or equal to, so greater than or equal to negative 2 and less than 2. So greater than or equal to negative 2, okay. And, so make sure you always less than 2. So x is greater than or equal to negative 2, and then x is less than 2. Okay. So we're going to graph our two numbers. Let's say this is 0, this is 2, this is negative 2. So we want a closed dot at x is greater than, or x is negative 2. And then we want an open dot, positive 2. So and means where they overlap, which is the middle here. And that's it. Okay, all real numbers x that are less than or equal to, so x is less than or equal to 3, or x is greater than 6. So remember, if we're putting or, we just graph them, doesn't matter. So we have, let's say this is 6, 5, 4, 3, closed dot, so either it can go this way, or open dot, or it can go this way. All real numbers, x. So x is greater than -8 and less than and x is less than or equal to -3. So and means where they overlap. So we have -8 here, 7, 6, 5, 4, 3, -3 there. We have a closed dot here, open dot here, shade in between. Okay, now let's combine everything we know. Oh. And something new at the same time. So, we're still trying to get x alone, but this time x needs to be alone in the center. So now we have two inequalities, right? We have three sides to this equation. We have the center, we have the left, and we have the right. So, but we do it the same way. So I'm trying to get x by itself, so I'm going to get rid of this -3 by adding 3 to all sides. So if I write that out, so I have 15 is less than or equal to 3x minus 3, less than 24. So I'm going to add 3 to all sides. So now I will have 18 is less than or equal to 3x, which is less than 24. Okay. 3 is being multiplied by x, so I'm going to divide by 3 to all sides. So 18 divided by 3 is 6, and then less than or equal to x, which is less than 8. Okay. So x is in between these two numbers. So let's call this 6 and that 8. So I have a closed dot here and an open dot here. We know x is smaller than 8 but bigger than 6. Okay. So this time we subtract 1 from all sides. Get 14 less than -7x, which is less than 50. Okay, now I'm going to divide by -7. Divide by -7, divide by -7, divide by -7. So 14 divided by -7 is -2, but remember now the sign flips. We'll get x, sign flips again, which is, oops, I messed up. 50 minus 1 is 49, and then divided by -7 is -7. So -7 here, 6, 5, 4, 3, 2 here, and we're going to make it an open dot, and x is less than but bigger than, yep, shade in between. And then here we go some more. Okay, checkpoint 1. -3 is less than or equal to -2x plus 1, which is less than or equal to 11. So subtract 1 from all sides. So -4 is less than or equal to -2x, which is less than or equal to 10. Now I'm going to divide everything by -2. So this is a +2, switch sides, x, switch signs, -5. So negative 5, 4, 3, 2, 1, 0, 1, 2. So x is less than or equal to 2, but bigger than or equal to negative 5. So shade in between. Two closed dots. So this one we have two separate equations. So basically we have two problems to solve. So let's work on this first equation. Minus 6, minus 6. So I have 5x is less than or equal to negative 15. Divide by 5. And we'll get x is still less than or equal to negative 3. So next, the next problem here, 2x minus 8 is greater than 12. Add 8 and get 2x is greater than 20. Divide by 2 and get x is greater than 10. So I'm just going to say that this is 10 and that this is negative 3. We have a closed dot here, and that goes that way. And then we have open dot here, and it goes that way. So that's our answer. All right, one more. So I'm going to write this over here. 9x plus 1 is less than negative 17. So I'm going to subtract 1 from both sides. I get 9x equals negative 18. Divide by 9. Oops, not equals. Less than. And I'll get x is less than negative 2. So remember, the sign only changes when we divide or multiply by a negative number. It's okay if a negative number is being divided by a positive number. Alright, next problem. Well, let's go ahead and graph that. X is less than negative 2. Actually, no, let's go ahead and solve the other problem first, because I don't know what x is going to be on that side. So I have 7x minus 12 is greater than 9. So I have 7x is greater than 21. Divide by 7, divide by 7, x is greater than 3. Okay. So I'll have negative 2 here, negative 1, 0, 1, 2, 3, 3 over here. We have both open dots. Going in different directions. Hopefully this helps you out. Have a good day.